NOTACON. Okay. Slashpackage, not as scary as it looks. Slashpackage is a package management system, kind of new and different, and has met with some resistance. I think people don't quite understand what it is, what it's trying to do, really. And so I'm hoping this presentation will help that for all of you here. So, it was created by Dan Bernstein about 4 or so years ago, and I've been a big adherent to it ever since. Yeah, best not to compare it to other package management systems because they're really attacking a different problem, or they're attacking the problem from a different angle, and one is really not a substitute for the other. They could even be used in combination. As a point of terminology, some people use the word package only to refer to, say, a repackaged version from an OS vendor, or only if it's in binary form. I don't really care to make that distinction right now. If it's a bunch of software distributed as a unit, I'll consider that a package. Okay, so, whoops, there we go, okay. The basics of package management, what problems do we try to solve here? We want to make installation of software easy. There are a lot of different ways people do things out there that if you try to install everything from source yourself, you're going to run into a lot of trouble, a lot of hassle. So we want to make that easier. We also want to make uninstallation easier. Once you're sick of this program, don't want to have it on your system anymore, you want to know where it put all its files, and so you want to be able to get rid of them without damaging anything else. You want to track dependencies so that before you start installing package foo, which depends on bar, you want to know about bar and get that taken care of first. Conflict resolution. Authors don't really coordinate their efforts very closely across the net, and so you might have two people using the same file name for two different things. The program xFirstStats could be provided by two different packages, and in fact has been. We also try to make different packages appear more or less similar, so that upgrading, installing, removing a package is pretty much the same process for the admin to do, no matter what the package is, no matter how the package itself, as distributed by the author, normally works. So the two problems out of that set that Slashpackage really tries to target are conflicts, different aspects of the conflict problem. You could have the same program in two different places, or you could have the same place, meaning a path, being used for two different files from different packages. So, for example, I'm distributing a Perl script. I want anybody to be able to run it as easily as they like. But I need to know where the Perl interpreter is to make my script work. And it could be in a variety of places. It could be in user bin, could be in user local bin, depending on how it was installed. So that's one problem. Also, now for other types of files like C header files or libraries, we have search paths to try to handle that problem. There are a variety of places we'll look for the file, so that even if it is installed in various different places, we can usually find it. But that's somewhat error prone too, because the search path for your C headers might not be in the same order as the search path for your libraries, etc., etc. So various problems can occur. So the Slashpackage solution here is, for any given file from a package, there has to be one path that will always work. No matter where you are, no matter how it was installed, no matter how else you might be able to find that file on any given system, you should at least be able to find it by the one standard default path. Now the other problem that Slashpackage tries to target is naming conflicts, collisions, where two packages have the same name or two files within those packages have the same name because the authors didn't coordinate, and really there's not been much expectation that they should. And so the result is that you have these collisions. And when you try to integrate both of those packages onto a single system, you have to resolve that conflict somehow. But you really, as an author of a dependent package that uses one of those two conflicting packages, you don't know how that conflict was resolved by any given party, and so you don't know what you should be looking for to find the dependency you need. And so the Slashpackage solution for that is we have a registry of all package names and all command names. So as a result, these conflicts don't come up in the first place. Yeah.
There's multiple versions of a single package following the same path, or is that a sort of separate problem?
Versions I will get to in a minute here. They don't count as conflicts. Yeah, feel free to jump in with questions at any time. Okay, so there's a question that comes up here with this registry is who's going to do the work of coming up with a standard path, as in the first problem here, and then entering that into the global registry to ensure that other packages won't use that path. So the classic net solution, if nobody else does it for you, you do it for yourself. And in this case, you is the admin, because the admin is the one who benefits from this work. So if an admin is doing this, first of all, this is not what your primary goal as an admin is. You're not really trying to make a package management system. You're just trying to run your system. And so what you'll end up with is probably kind of haphazard and sloppy, and it's just enough to get you through the day where some other problem becomes more important. There's also a massive duplication of effort. If every single root is doing this themselves, everybody's work is wasted. It would be much better if we could have the same work done once and everybody could benefit from it. And as I mentioned before, when the conflict resolution is done, it can be done differently by each person, so that makes a portability problem for other software that depends on it. Also, I described it here as package normalization. What I mean by that is on one system you can find all your programs in user bin, let's say, and on another system maybe you find them in opt somewhere. On any given system, everything is made to look pretty similar across different packages, but that's another point where the way things are done on one system is not going to be the same as the way things are done on another system, and so that becomes a problem again for portable software that depends on those things. So after all these admins get sick of doing everything themselves, they will start to band together, and then you get an OS distribution out of that where all this work of conflict resolution and normalization and stuff is concentrated in a distro, and then everybody can make use of that. Now there is still some duplication of effort and some portability problems. There's less because there are fewer distros than there are admins, but those problems do still occur, and they can still be just as frustrating. Also, the distros out there can't keep up with all the upstream sources out there. The authors producing this software there's very many of them. They can come out with new versions on a fairly rapid cycle sometimes. And so if you're an admin and you want one of these packages, or one of these versions at least, that is not yet available through your distro, then you're stuck. Even though the distro is supposedly doing this work for you, you're still stuck doing this work yourself. And now you've got the problem of sometimes I deal with packages the way my distro does it, sometimes I have to do it myself. So that's more work there again. So pushing it even farther away from the admins, we reach the point where how Slashpackage does it, the authors do the work of the normalization and conflict resolution. Now we have no duplication of effort. If the ultimate author of a program decides what its name will be and how it's going to look and make it pretty much the same as other packages so people won't be tempted to make any changes, then that only has to be done once. Nobody else has to do it again, and everybody benefits from that work. That does concentrate more effort on the author than has been traditionally done, but with automated tools it's usually not too tough. The portability problems go away since everybody's using the same version. Of course that's sort of disingenuous. It actually depends on people not making changes, which they have always done before. Why would they stop now? Well, there has been effort put into it to make it less necessary for people to make changes. And so if they don't make changes, incompatible changes I should say, then we won't have to worry about these portability problems. I create a program, I put a lot of work into making it work pretty well on every system I can find. I make it available for everybody to use. Then when they get it, they can pretty much use it as is, and I encourage them to. That way anything that depends on that program will be able to find it right where they expect it to be. Now, people will still have the temptation to make all these different packages look the same on their own system, but you can usually do that by adding a layer with symlinks or whatever. You want all your config files to be in Etsy, or you want all your programs to be in one directory. You can do that with symlinks. You don't need to make incompatible changes to the program or to the package. If the author does this work, then the distro can use pretty much the same format, same layout, same everything. They don't have to make many changes. That means when the author does reach the point, or I'm sorry, when the admin reaches the point where they want to go get something themselves that's not available through their distro, it won't be so different from what they already know from their distro. And so that's less work for the admin. They can work with that direct package pretty much the same as they work with any package. Yeah, which makes uninstallation easier, and that means that you have less resistance to try new things, which I think is good. If you know that this new package that you want to try looks kind of interesting, there's a decent chance it won't be useful actually. And so, you know, you may end up uninstalling it, getting rid of it. There's less resistance to try it if you know that it will be easy to get rid of it. And now when the authors are doing the work, you can't really use something like RPM or apt or whatever and try to push that out to everybody, because everybody doesn't have RPM or apt. A lot of people will have RPM or apt, but if you pick any one, you're kind of stuck. So the format used for distribution has to be simple, portable, depend on very basic things that everybody has. And once you've done that, the way Slashpackage does it is the package database is actually in the file system. Every package is in its own directory, and so that directory in the file system is the record of that package being in there. So that eliminates a layer. When you're using RPM or whatever, you've got a record in the package database and you've got the files in the file system, and as long as you've got that duplication of information, there's the possibility for those pieces of information to be inconsistent. You could have the files and it won't be in the package database, and then you have trouble installing dependencies or dependent packages. Or you can have the record in the package database, but you don't actually have the files for whatever reason. And that can cause trouble. And with the simplicity of the /package format and the layout, it makes it very easy for anybody who wants to create higher level tools to manage their packages. I've got a bunch of tools that are just simply shell scripts that can install and uninstall packages. And it would be easy for anybody who doesn't like the tools that are out there to create their own, because everything is done in a fairly simple way. So I mentioned before registration, and for registration we'd like to look at other registration systems out there to get an idea of what a good registration system looks like. And I think DNS is an excellent example. It's a hierarchical namespace. The file system is also a hierarchical namespace. With hierarchy, you have the opportunity for delegation. Yahoo.com is delegated to Yahoo. We can find a file prefix, a path name for a directory, and delegate that. Anything within a domain name or within a directory can be controlled by the person we delegated it to. And that really reduces the amount of coordination necessary. We don't worry that there's more than one computer out there called www, because they're all in separate domains, so there's no confusion, there's no collision. The same thing applies with files within a package here. If they're all in their own directories, they won't conflict with each other. The one exception to that is command names. Those are all squashed into a flat namespace by way of $path, the environment variable. And people are used to just typing the name of the command, and that'll get them the program they want. They don't really want to have to type in a full path, and people type commands a lot, so it's good that they should be able to do just the base name of the command. And so we register command names too, along with package names. But we do not need to register header files, libraries, pretty much anything else. Those, it's usually not too much trouble to find those by their full paths. And so if we do find those by their full paths, they're automatically distinguished by the directory for the package they're in. We don't need to coordinate to keep their base names distinct. And so if all this seems vague so far, hopefully this will make it more concrete. The file system layout. We have the /package directory. Under that we have category directories like package misc. Under that we can have either more category directories, or we can have package directories themselves. So we have package misc fd tools is a symlink pointing to the current version of the fd tools package. That'll be, in this case, package misc fd tools -2004.12.17. I like to use dates in my version numbers, but not everybody does, and this /package spec allows for pretty much any kind of version number scheme you want, as long as it starts with a digit. There's also implicit delegations, so you don't always have to use the registry for everything. If you own a domain name, like in this case scarnet.org, the owner of that domain publishes some /package packages, and he used the package path /package/host/scarnet.org/minutils. That's a package, and it's automatically delegated to him because he owns the scarnet.org domain. He owns everything under package host scarnet.org. Now within each package, we've got a variety of things. Here on the left you see the various top-level directories within a package. Command contains any commands provided by the package. Conf is the way I do configuration, I put my config files under there. Conf compile contains any compile time configuration files. Then you've got include for header files. Library is the convention that popped up instead of just lib, spell it out as library, not a big deal. Packages could even do it differently if they like, and there wouldn't be much problem with that. There's not really need for a unified convention, but it's kind of nice, so pretty much everybody does it that way so far. The package subdirectory contains a lot of the metadata about the package, which is listed on the right here. And then finally, the source directory contains the actual sources if you're building a package from source. Some of the metadata within the package directory is you've got an install script, which usually breaks down into 3 basic steps. Compile, which creates everything within the package directory itself. Upgrade, which sets that current version symlink you see above there, and also creates the symlinks for all the command programs so that they're in /command and also in user local bin, so that they'll show up in $path, and your $path doesn't grow to some huge long string to contain every package on your system. The last step of package install is package run, which starts up any processes necessary to make the services of this package available on your system. In most cases, that's not really used because you might want to have more than one instance. You might want to set it up in various different ways, and so there's not really much that can be known at install time about how that should be done. And so in the vast majority of cases, package run is a no-op. You've also got package sharing, which is, this one's not a script. It tells you how shareable these various files are. So for example, the source directory, that's portable to any platform, at least any platform that the package will run on at all. Those files are going to be the same on all those different platforms. So you can just store one copy of that. If you're running a heterogeneous collection of systems, you can just store one copy of that source directory somehow and make it available on all the systems. Whereas the command directory or the library directory, that will contain compiled code, so that will be specific to a certain architecture OS, and so you'll have to store one copy of that for each kind of system that you're running. The package versions file tells you a list of versions of the package. That's mostly so it contains all the versions up to date, and so you can, if you're looking for version 1.2 or newer when you're doing dependency tracking, you can look in that file, and if you see 1.2 listed, then you know that this package is at least as new as version 1.2, and so it should be good to use. Is that all clear? I'm sure yeah, anyway. So, this versioning, where you see here the version number is part of the path that the package is installed as. That means different versions go in different directories, and so you can have multiple versions installed at the same time and they won't conflict with each other. That's useful when you want to test a new version. You still want the old version for production use. You're not entirely sure you trust the new version yet, but you can put it on there in the normal way. You don't have to do any special work to put it somewhere else, and you can try it out from there, and then finally when you're ready, when you do know that you trust this new version, then you can update that current version symlink and you'll be all set. That updating of the symlink is just a single atomic operation, and that upgrades your whole package instantaneously. So for example, there is zero risk of, okay, something on the system invoked this command, and the command had been updated already, but one of the libraries it links to hadn't been updated, so I got the new version of the command and the old version of the library, and something bad happened. That can't happen here. When you run the version, when you run a command, you'll either get the new version or the old version, and if the symlink has been updated, then you've got the new version of everything. If it hasn't, you've got the old version of everything. This also doesn't do anything to get rid of the old version. So if a problem crops up later, you can easily downgrade back to the old reliable version, and you're all set. There's no risk of damaging anything that you had before. Any of the code, anyway. But when a package refers to its own files to make all this work, it will pretty much have to use the path that includes the version number. Anything within that version will refer to something else within that version. That way, something can work even when it doesn't have the current version symlink pointing to it. Whereas anything outside the package that depends on it would typically go by way of the current version symlink, and I don't know what version it is, I don't care, just as long as I've got something I can use. So now the process for building and installing a package like this is pretty straightforward, and it's pretty uniform for all packages. You get yourself into the /package directory, you untar your tarball from there, and actually that tarball will holds the files in the paths in the tarball actually include all the category directories and everything, so that you untar it from /package and everything shows up exactly where it should be. So then you jump into the directory of the package itself, and from there you can just run the package/install script and everything is magically done. Or if you like to look at things at a finer level of detail, you can run package/compile, which will create all the files within the package. In my packages, convention I use is I have a package/own script that's included here. So far it's a no-op because none of my packages need it, but the purpose of it being there is if you need to set any specific ownership or set UID, set GID bits, that can go there. That obviously would have to run as root, but package compile only needs permission to write to things within the package directory. That doesn't have to run as root. So that's kind of nice for... It won't really protect you against malicious attacks. If you're installing somebody's package and it's a Trojan, you're pretty much stuck. But if there are inadvertent bugs that could damage your system if they were run as root, and if those were in package compile, you'd be protected against those by running that part as non-root. The package/check, also a no-op in my packages so far, but that's where a test suite could go. Package/build just runs those first three. That seems like a logical set of things to tie together because those things only modify files within the package directory. They never need to step outside. Then after that you've got upgrade version. Again, this one is only specific to my packages. I've not seen other authors adopt it so far. That sets the current version symlink. Install commands installs all the command symlinks. Upgrade, package/upgrade runs those two together, upgrade version and install commands, and that one is more commonly found in pretty much all /package packages. And package run, as I mentioned before, usually a no-op. Package elsewhere is something I threw in there, thought it might possibly be useful. I actually haven't had much need for it so far, but it's sort of the equivalent of make desdir equals wherever. It will produce a copy of the package in some other place so that you can build another copy with a different compile time configuration, or however you want to do it for comparison like that. Maybe throw in debugging compiler flags. How are we doing on time? Okay. So, speaking of compile time configuration, the way it's typically been done in Slashpackage packages, and something that I really like about this system, is you typically have just one file per configuration parameter. So, how to invoke the C compiler, how to invoke the linker, where are my dependencies, where am I if you're installing the package in some non-standard location, which typically you should avoid that, but if you're not root, you can't really help it. So these things, each one is represented in its own file. The benefit of that, as opposed to having a bunch of variables in a makefile or whatever, is that it's very easy for programs to read and to write that information. You want to know where this one dependency is, you just slurp in this one file and that's where it is. Or actually the way I do it is the first line of the file is the value of that parameter and the rest is a description. So that's a nice way to make it self-documenting as well. Runtime configuration is pretty much similar in my packages, at least. Anything that applies to the whole package has to go in the package directory. Whereas if you're running a web server, for example, you could be running multiple instances of that, and so that configuration data doesn't really belong in the package directory because there could be more than one of them and they can't all have the same name. But anything that does apply to the whole package would go in there, and the way I do it, it's pretty similar, one file per parameter, and so far the only kind of configuration like that that I've needed is where do I find my dependencies at runtime. And the way I do that is I've got a dependency compile time configuration file where when you're installing the package you can say if one of your dependencies is in a non-standard place, you can say it there, and then the build system will create a symlink to that and put that in the runtime configuration directory. Then I always find the dependency by way of that symlink, which is in my own package directory, so if it ever needs to change, that can be changed independently of anything else on the system. So for example, you've got package foo and it's needed by packages bar and baz. Well, maybe bar needs version 1.2, but baz needs version 1.3. So you can have foo 1.2 and foo 1.3 installed at the same time, and bar and baz can both use the versions they need, and those don't conflict. The way you see this handled typically right now without Slashpackage is version numbers are embedded into library file names and all sorts of things. I think that's kind of messy. So now we've taken all this work away from the distro. Is it still meaningful to have a distro? What's left for a distro to do? Well, distros do a lot of QA work, and that's certainly valuable. The question then becomes, how would a distro play nice with Slashpackage? And if a distribution wants to say, okay, we've tested this combination of package versions, they work very well, you can rely on them pretty much. What they could do is they can use the package host automatic delegations, and they can set up this symlink here as an alias of another package. So package host vendor.com admin foo is just a symlink to a specific version, the version they've tested of package admin foo. And then if the admin decides, I want to try out version foo 1.3 and use it for most of my own things, I can install foo 1.3 and I can update the package admin foo current version symlink, but the vendor's symlink still points to foo 1.2, and anything of the vendor's code can still find foo by way of their own vendor symlink, and so everything works. You can still, if you like, wrap all these files in your old package format if you want that kind of normalization. That won't break anything. The main thing is that once the files are on the system, you can find them by their standard paths. That's where the portability benefits really come from. Shared libraries. Basically, it is possible to do these without having one global search path that includes every package's library directory. There's a couple of different ways to do it. You can either I have my own search path for my package that looks in just these library directories for my dependencies, or you can put absolute paths in the SO name so that I link directly to the file I'm looking for without any searching needed. That at least works for ELF-based shared library systems. Not so sure about others. I don't really know. Slashpackage is about 4 years old now. Little more. The earliest reference, I have a terrible memory for time, but the earliest reference I could find for it was archive.org had the webpage at February 2001. I subscribed to the mailing list in January, but there wasn't any traffic till February. And in that time, it has undergone some evolution. There is still room for more improvement. One thing that I'd like to see is the URL for a package tarball could be included in the registry. So that way, a higher level tool can say, I want to install package admin foo. Okay, go look at the registry, see where that tarball is, automatically download it. No human intervention needed. I kind of suspect that's not going to happen, so I just might set up that sort of thing independently of the registry. And that would still work just as well. Configuration, I mentioned the way I do things. Other packages tend to do things pretty similarly. We're all kind of cut from the same cloth so far. The adopters of Slashpackage have usually a common aesthetic taste up to this point, but everything is not quite the same, and so it would be nice if we had some kind of spec for how that should work, and that would make things easier on the users. There could be room in the spec for more things like, once you've built this package, can you delete the source directory? In many cases, yes. In a few cases, there are packages that still need to refer to things in their source directory at runtime. If you've got something like a spool type directory for a mail manager or anything like that, it would be nice to somehow declare that this directory needs to be writable at runtime, and then a higher level tool can take the parts that need to be writable and the parts that don't and move them off to appropriate file systems, and then of course leave symlinks behind so that the standard access paths still work, but everything can be physically stored the way the admin wants it. Some of these higher level tools I've been talking about, I've written some, and since the package format is so simple and straightforward, these are pretty much just simple shell scripts. I've got one sp install that you give it the name of a tarball that's that you've downloaded, or you can give it the path to a package in some cases, and it'll install that package. Some of the installation code, the setting the current version symlink, the command symlinks, that is really going to be the same for any package, and so that's included in sp install just in case there are bugs in that part of the code in any given package, which there are in some cases. In the case of upgrades, sp install can actually automatically locate and download the new version if the old version that you already have installed includes the appropriate metadata. For first-time installs, that's when you need the URL to be included in the registry or at some central location. and that there is not there yet, but I'd like it to be. SP install can also do some automatic configuration. If you're installing things in your home directory, you can say, install this in my home directory and also look for dependencies there in case they're not in the root/package directory. Then I've got a couple other things here. SP check and SP globals kind of look over the system to see what you've got installed, look for anything unusual. As an example here, we can see what SP check finds. Here in the under package misc SPF, which I'll get to in a minute, it's finding lots of things because I'm pretty sloppy on my system, the way I admin it in some ways. So you've got all these multiple versions, that's not a problem, of course, but it is somewhat odd, and so it's reported here, and various other things like that can be reported. Oops. Yeah. Okay, so now SPF, which let the irony and hypocrisy ensue. SPF, of course, is on the one hand a name of a borked anti-forgery mail system, but when I'm talking about SPF, I'm usually talking about my /package foreign project, which takes packages that are already out there and installs them in a /package-like way. Now, the hypocrisy of this, if you want to call it that, is that I'm changing program paths. I'm making the old path not work anymore. This is exactly what /package was supposed to prevent. Dan Bernstein, who created /package, doesn't really like this idea, but I see it as a trade-off, and it's a trade-off I like. I am giving up some of the portability benefits there. I'm making more work for myself when I want to install a dependent package. I have to tell it where to find everything it needs. But the atomic, reversible, non-destructive upgrades, that's something I really like, and that is a benefit I get out of this. And so here we see some of the paths that you might end up with in this system. This is actually not the way things are done right now. These are not the paths you saw a second ago, but this is the way I'm in the middle of rewriting a lot of the system, and this is what it's going to look like in the future. Real soon now. And if you ask me again a few months ago, I'll tell you the same thing. Yeah?
The changes that you make in your build scripts when you go outside packages to your hierarchy, are those things you can submit back to the individual software maintainers that they can accept or not?
In some cases, there are things that I like to submit upstream. This is usually adding the flexibility to install things this way. I would not, of course, submit upstream to make this the default, because that's a much bigger change. But, like, for example, a lot of things will do a test for the exact file user include whatever. And so I may submit a change upstream that says, instead of testing for that file, try to compile a test C file that includes that file, and let the compiler figure out where that file actually is. That's a pretty common one. So the way this path scheme would work in the not yet existent SPF system is every package can be repackaged by pretty much anyone, and they can distribute their own repackaging under package host and their domain. So, for example, I have the domain dogmap.org. I put all my code on code.dogmap.org, and so I can install the package host code.dogmap.org/foreign/bash 3.0. And that can be my take on how to install bash under /package. And within that directory, it'll look pretty much like any other /package package. I can install GCC 343 I can install glibc235 under /package. It doesn't have to be in the root. This does take some special extra magic work, but as a result, I have no /lib. I don't need a /lib. Wait a minute, how does everything find its dynamic linker if there is no /lib? Well, let's just say there are ways. I treat glibc like any other dependency. And so, for example, bash finds its dynamic linker as a path within its own package directory. And those paths are configuration symlinks, just like I was talking about before. And it is some kind of deep magic, a little bit. It is a little bit scary, but it works. And that's another reason why I created this project, is to do as a proof of concept. Some people might think that there's no possible way you could create a whole system this way. Well, I did. And it was fun. Okay. Maybe you like this. Maybe you don't. The main thing I'm trying to get across here is that /package is primarily targeted at authors and not at repackagers, distros, admins. The main thing for anybody downstream to do is not make incompatible changes, which would result in portability problems. The authors have to do the bulk of the work here. If you like these ideas, here are some links you can look at. The /package spec on Crypto, Dan Bernstein's site, the mailing list. If you're an author and you want to get in on this scene and you want a build system to help you along, it certainly helps. I've got one that I made that was actually the first /package package, was my build system for /package packages. At the time it was pure shell code, didn't even invoke any external commands, and it produced makefiles and such. I've got one on superscript.com. You can find William Baxter's build system called Build, and on Crypto you can find a little bit of documentation for Dan Bernstein's system, Redo. He hasn't published the code yet, but looking through the documentation you can get a pretty good idea of how it works. And it wouldn't be too hard to do something similar on your own if that's what you like. If you're an admin and you like these ideas, SP Tools, as I mentioned, can help you manage the packages installed on your system. SPF, if you really like it, you may want to hold off a bit until the rewrite's done. Then again, who knows when that'll be. So that's pretty much it. Yeah?
If somebody wanted to run a /package foreign system, the whole thing, what does it take to bootstrap?
Most recently, I booted off a Knoppix CD and formatted the hard disk and started installing stuff off of that, and then once I got enough on the hard disk that I had installed that was workable, I can reboot into that and continue installing things from there. I've also at some times copied binaries over from an existing /packagized system and then reinstall there, just because I like to do that. Well, with the SPF system right now, I'm publishing maybe 20% of a distro, the packaging framework. I am not too eager to get into all the QA work. I'm more than happy to factor out the parts of being a distro and take on only some of them. If somebody else wants to do a lot of QA work, they can do that. They can do it using SPF if they like. If somebody else wants to provide /packagized binary packages, I don't get into that, but if somebody else wants to, and I think some people have, they can do that. And so that helps to spread the work around a bit. Okay. All right. Thank you.